Hello. Hello.
Hello.
Yeah. Hi. Uh, we'll do problems on this. We have already discussed the theory part for this, right?
Right, we did.
So we'll start off with any doubts you have, any problems that you have faced. Otherwise, I will share the questions.
I did have a few,
Yeah.
but most of them were from actually the
Uh,
functional equations.
functional equations part.
Yeah.
Okay. So show me. Do you have it somewhere? It is from your books or from the
No, no,
motion?
from the material you sent.
Okay. So which question? This is the motion book.
Yep.
Okay. Theory and exercise, that one, right?
Yes.
Uh,
Um, the 15th one we had did it in class, but then you said you'll get back to me with it later.
which 15th one?
Yeah.
This is example 15.
No, this question 15.
One sec. What is the question? Which question are you talking about?
Let f of x plus y is equal to f of x into f of y. All x and y, suppose that f of 3 is equal to 3.
F of
Dash,
x plus f of y.
no, f of x into f of y.
Correct. So this was okay. I cannot find the question right now. Where was this in the book? What is it? Some exercise question? No.
Yeah, exercise 1, question number 15, page number 31.
Okay. Okay. Question number 15. Yeah. Yeah. F of 3 is 3 and f dash of 0 is 11. F of 3 is 3. F dash of 0 is 11. And we were supposed to find out f dash of 3.
Right.
Dash of 3. So the problem was that
We got it 33, but it was only because we knew that was the only thing divisible by 3.
that was the only thing that was divisible by 3. But how did we know it should be divisible by 3?
We took a
Because
very general case of e to the power k's.
because e power kx and all, if it is like this, then kx plus y will be equal to e power kx into e power ky,
Yeah,
right?
right,
So if my function is e power kx, then e power kx is equal to fx. Then when you put 3, you get e power 3k. E power 3k is equal to 3, right?
right,
So 3k is basically log 3, right? So k is equal to 1 by 3 log 3. You're getting, right?
right,
And f dash of 0. So f dash of x will be k e power kx. And when you put 0, you get k e power 0. So k. Why is that coming like this? Because, oh, because we have to take even more general case. You have to take c e power kx
right,
is your fx, because then right now, otherwise what is happening? K is coming as 11, right?
right.
And here it is coming different. So that means there are two variables.
Yeah, here it will be c, not k.
Huh. So now it will become, we have two equations, two unknowns types, right? So you will
Right,
be able to find c and k. And f dash of 3 would, you will use the fact that f dash of x would be simply ck. So k times c e power kx, right?
right,
So this is f So we know that k times f of x, right?
Right.
And f of x is 3, right?
Yeah. Yeah.
At 3 it is 3. So f dash x must be 3k. So 3 times some constant. So only option that is divisible by 3 is 33, right?
Right.
Uh, so that is a solution that uses the fact that I know that this property is satisfied by exponential functions. Exponential functions. Uh, Exponential or logarithmic, it's the same thing. Both log and exponents. Actually, log will not satisfy this property. So only exponential functions, right?
Right.
So we are using that to reduce that. We'll get this. In general, to prove that this has only this solution is slightly beyond the scope of the discussion here, because this is actually a famous functional equation. I think Cauchy's functional equation. Cauchy's equation. And the proof of this is a little advanced. It you will have to use mathematical induction, I think, because otherwise what we were getting in the previous class is that f of 2x was equal to f of x whole square and stuff, right? Things like this what we were getting. Also, f of 0 was equal to f of x into f of 0. No,
Right.
f of x was equal to this, right? Y
Yeah.
is 0 I have put. So that means that either f of x is 0, which is not which is a trivial solution, or f of 0 is, subtract this, 1, right? F of 0 must be 1.
Yeah.
So if f of 0 is 1, you have, oh, okay. So notice that this k part is coming as 11 or something, no? F dash 0 is coming as 11.
11.
But that we are again thinking of the fact that it is an exponential function.
Function. Yeah.
Without knowing that it is an exponential function, right now we only know this much. F dash 0 is 11, f of 3 is 3, and okay, this is the information that we now know. F of 0 is 1, f dash 0 is 11, f of 3 is 3, and these types of things are happening. So f of 3x, if you see, would be f of x into f of 2x will be f of x whole cube, right?
Yep.
Right. So f
Right.
of 3x will become f of x whole cube, and so on. So you are clearly seeing that if you increase the power here, increase the coefficient here, it goes into the power, right?
Right.
So that again suggests that it is some exponentiation,
Special function. Yeah.
right? But
Right.
general proof will probably, how will we prove this statement? So, okay, so what we can do is, if we, okay, one thing that we could try out is this. So we have sort of proved that f of kx is equal to f of x to the power k, right?
Right.
For k being a natural number, for k is a natural number. So that is obvious that we can prove, right?
Mm.
Then differentiate both sides, f dash kx into k, right here,
Yeah.
is equal to k times f of x to the power k minus 1 into f dash x, right?
Right.
Correct. So this k cancels, and what we are getting is f dash kx is equal to f of x to the power k minus 1 into f dash x, right?
Yeah.
So f of x to the power k minus 1 can be thought of as f of k minus 1 into x, right?
Yes.
Correct. So we are
Yeah.
getting something like this, right?
Yes.
And this thing, since we have f of x plus y is equal to f of x into f of y, right?
Yeah.
So we can say f dash kx is equal to f dash k minus 1 into x plus x, right?
Yes.
So that becomes f dash k minus 1 into x dot f dash, no, uh, okay, slight problems, because we don't know whether this product will split like that, or derivative will split like that, right?
Right.
We know f dash kx. I wanted to split this as k minus 1 and 1, right? But the derivative, okay, so what we know is f of kx is equal to f of k minus 1 x into f of x, right?
Right.
So if I do f dash kx in this equation, right, it will be by product rule uv function, it will be f dash k minus 1 x
X and f
f of x plus f
dash
of
x.
k minus 1 x into f dash x, right?
X. Yeah.
Right. So this is coming. So if I equate it to this side, f of k minus 1 into f dash x is there, right? So you are getting, this is 0, right? This cancels, no?
Right.
You are understanding what I'm saying? Uh, this part must be equal to this, right?
Yes.
So one of the terms just completely gets cancelled, no?
Cancelled. Yep.
So you're getting f dash k minus 1 in x into f of x is equal to 0, right?
Yes.
So that means that since f of x cannot be 0, this must be 0.
0.
If this is 0, then f of k minus 1 into x, f dash thing is 0, then f of k minus 1 into x is some constant, right?
Right.
Right. So 1 second, just hold on for a second. Okay. So we are getting this thing, right? So what does that mean? That, okay, so that thing is some constant. That seems wrong. Uh, Something seems to have gone wrong. I was hoping that I would be able to prove it, but uh, see, this itself suggests again exponential. So I think we should be just satisfied with the solution that we have. If we have exponential, we have already proved that the answer will be 3k, right?
Right.
Uh, there must be a nicer proof also, but right now I'm not getting it. Okay. Uh, yeah. Let's move on. It's fine. Uh, Doubts. Let me tell me your doubts
I
and all.
get the 16 sum either.
16th one.
Yep.
Okay. 16th one is f of r to r is a differentiable function such that f of x plus 2y, f of x plus 2y is equal to uh, f of x plus f of 2y plus 4xy, f of x plus f of 2y plus 4xy for all xy belongs to real, and you have to get now f dash 1, and f dash 0, the values of this. F dash 1 is equal to, you are getting f dash 0 plus 1 is one option, plus 1. and f dash 1 is f dash 0 minus 1 plus minus 1, and the other options are f dash 0 is f dash 1 plus 2, or okay, f dash 0 is f dash 1 plus minus 2. These are the four options, right?
Right.
Okay, so what we will try to do here is use the fact that this is differentiable. So let's try to understand what is f dash 1 and what is f dash 0, right?
All right.
So this is limit of h tends to 0, f of 1 plus h minus f of 1 by h, right?
Yeah.
And this is limit of h tends to 0, f of 0 plus h minus f of 0 by h, right?
Yes.
Okay, so can we find out values of f of 1 and f of 0 somehow, like using this? If I put 0 for both, what happens? It becomes f of 0 is equal to
F of
2
zero.
f
F,
of 0
right.
plus 0, right?
Yeah.
So we are getting either f of 0, or actually f of 0 is 0 we are getting, right?
Right.
So now we know that this f dash 0 is actually limit of h tends to 0, f of h by h, right?
Right.
And let's try to find out value of f of 1 if we can. Uh, if y is equal to half and x is equal to 1, x is equal to 0, what comes? No, what is coming? Y is equal to x is 0, let's say. Okay, they will get f of 1 is f of 1, right? X is 0, y is half. You got f of 1 this side, and x is 0, this is 0,
Zero,
and
then F of
1.
one.
We'll get f of 1 is equal to f. That is not you working out. So let's put 0 and 1. What comes? Uh, or 1 and 0 first. So 1 is equal to f of 1
One.
plus
That's F of zero.
0. So that is also useless. 0 and 1. So 2 is equal to
Of
0,
zero
so
plus
0
F.
plus f of 2 plus, that is also useless. Okay, let's put 1 and 1 then, right?
Right.
That will be f of 3 is equal to f of 1 plus f of 2 plus 4.
Right.
F of 3 is f of 1 plus f of 2 plus 4, and f of 0 we know is 0, 1 and 2 we don't know right now, right?
Right.
1 and 2 we don't know. Okay, so if you put 0 and, okay, we don't get anything from there. So 1 and 1 I have put, 1 and minus 1 if I put, this is 1 and this is minus 1. Okay, that doesn't work because we don't know minus 1. So that was just introduce a new variable. So why don't I put y is equal to x here? So I get f of 3x is equal to f of x plus f of 2x, f of x plus f of 2x plus 8x, no,
4x squared.
4x square. Okay, this is a condition, and if you put uh, okay, of 2y is there, 2y, so this is 2 into x into 2y, right? This is 2
Right.
into x into 2y basically.
Yep.
F of x plus f of 2y plus 2 into x into 2y. Okay, so f of a plus f of b plus f of, so we are getting something like this: f of a plus b is equal to f of a plus f of b b plus
F
2ab,
2AB. Yeah.
right? Where b is the 2y part, right?
Right.
So, hmm, okay. So that means f of 1 plus h, f of 1 plus h can be written as f of 1 plus f of h plus
It's 2H.
2h, right? 2 into 1 into h, right?
Yeah, 2H.
Correct. And subtract f of 1 from there. So I'm looking at this one, right? So subtract f of 1 from there. So this becomes f of h plus 2h, right? Right?
Right.
By h. So now notice that this becomes limit of h tends to f of h by h plus 2, right?
Right.
And this part is f dash 0, f
0.
dash 0, no?
Yeah.
Plus 2 is equal to f dash 1. You understand?
Yeah.
It comes by using the condition nicely. So we didn't need to actually find these things. This was just experimental stuff. We only needed our f of 0. F of 0 was needed because we simplified the second derivative, right?
Yes.
And then f of 1 plus h, we used directly the formula that is given, right?
Yeah.
And then subtracted. So the thing to learn here is that you are using the limit definition to solve and the functional equation together with the limit definition.
Yep.
Okay.
Yeah.
So we are getting the option number C or D, whichever one. No, we are getting, which one are we getting? I think D we are getting, because minus 2 it will be. We are getting f dash 1 is equal to f dash 0 plus 2. So f dash 0 is f dash 1 minus 2, right?
It's option C.
Huh.
No, option D. Yeah.
Okay. You got it, no?
Yeah, I got it.
Okay. Next one.
Next one was 21.
Okay. A point where function fx is not continuous, where fx is equal to this. Fx is equal to GIF of sine of x, sine of GIF of x, in 0 to 2 pi, in 0 to 2 pi is what? A point where it is not continuous. Okay. So in 0 to 2 pi, this is x belongs to, and he's saying a point where it is not continuous, and the options are a 3 comma 0, 2 comma 0, 1 comma 0, 4 comma minus 1, 3 comma 0, 2 comma 0. See, this is a point, okay?
Yeah.
1 comma 0 and 4 comma minus 1, right?
Right.
So, okay. So, so first of all, you have to understand that this stands for x comma y, okay? Because he's talking about a point, no?
Yeah, I
He's
got that.
not talking about any interval and all, right?
Yeah.
So, okay. So we have to first think about why is it discontinuous. It will be discontinuous because of these GIF things, right?
Right.
So the easiest way to do this would be to check from the options, right? Because otherwise I'll keep searching for points, but right now I might as well just think about what happens at each of these points, right?
Points. Yeah.
So 3 comma 0. So if you think of the point 3 comma 0, x is equal to 3. So fx will become GIF of sine of
3.
GIF of x. So now let's go from 3 minus side, right?
Right.
If you go from the 3 minus side, continuity means both sides limits should tend to the function value, right?
Right.
So first let's find function value also. Function value f of 3 will be GIF of sine 3, right? Now for sure sine 3 is less than 1, right?
Yeah.
Because it's not some pi by 2, no? If it was some pi by 2 or some multiple of pi by 2, then only it can be 1, right? Exactly.
Yeah.
So it must be less than 1. So GIF is 0, right?
Right.
So function value is definitely 0 here, right?
Right.
Now when you approach from the 3 minus side, right? So then it will become sine of this GIF will become 2, right?
Yes.
Because it is slightly less than 3. And
Yeah.
that value also tends to 0,
0.
right? Or maybe, no, we have to be careful whether it is negative or not. Oh, okay. That part we have not been careful here, right? You
Yeah.
understand?
Yeah.
This is 3, right? So 3, and let's think about it's in the fourth quadrant, okay? 3, because no, it is less than pi, just less than pi. So it is in second quadrant, right? 3.
Right.
So since it is in second quadrant, it is positive. So it is 0 is correct, right?
Right.
And 2 is also in the second quadrant, no?
Yeah.
So it will be positive. So this will be 0, right?
Right.
So left hand tendency is 0, right hand tendency, let's think of. So since it is from 3 plus, now it is GIF of sine 3 only, right?
Yeah.
And that is also 0.
No.
So it is continuous here, no?
Right.
Uh, the same thing if I do here, notice that since 2 is also in second quadrant only, no?
Yeah. So it will also tend
2
to 0.
minus and 2 plus both will be continuous because positive it will be and it will be tending to 0, right?
Right.
1 also will be positive and tending to 0. There is no doubt.
Yeah.
But 4 comma minus 1, let's do it carefully. So first of all, let's find the value of f of 4. So that will be sine 4, which will be slightly in this quadrant. No.
Right.
So sine 4, since it is negative, the value will be minus 1 of this GIF outside.
Yeah.
So the value of f of 4 will be minus 1. Now we have to look at the tendencies. Now one tendency would be lim 4 minus, right? From less than 4. So it
Yes.
will be sine 3 then,
Yeah. That will
and
tend to.
then that will be 0. And above 4, right?
Right.
Then it will be sine of 4, but that will be tending to minus 1, right?
Right.
So the tendencies are different here, and therefore it is discontinuous.
Got it.
So this part will be discontinuous. These three are continuous because they are in first and second quadrants only, right?
Right.
So in general, if you are searching for a point discontinuity or discontinuity at a point, it might be more convenient instead of looking for searching for points yourself, look at the options and see if it is continuous or not.
All right.
Okay. Then what else?
23rd.
Okay. 23rd function definition is given. It's a piecewise defined function. Fx is equal to uh, root x 1 plus sin x if x is positive. Root x 1 plus 1 plus sine 1 by x plus sine 1 by x if x is positive, and minus of minus root x minus of root of minus x 1 plus sine 1 by x if x is negative, 1 plus sine 1 by x if x is less than 0, and 0 if x is equal to 0. You have to find out whether it is continuous or differentiable at this 0 point, right?
Right.
At 0 point, what is the nature? So okay, fine. So for let's check continuity first. F of 0 is clearly 0. So we have to now check the tendencies, right?
Right.
So limit of x tends to 0 plus, let's say. So in that case, the function is this one, right?
Right.
So it is root x 1 plus sine of 1 by x, right?
Yeah.
So if it was, see, think about it, if it was just sine of 1 by x, right?
Yeah.
Just sine of 1 by x, limit of x tends to 0 plus, then we will say limit does not exist,
Right.
right? Because it will oscillate very wildly, right?
Yeah.
Like this, because this is becoming infinite. So many times it has to oscillate, right?
Yep.
However, The problem is that this oscillation, no matter what happens, you can say that it will be less than plus minus 1, right?
Yes.
So what you can say is that root of x 1 plus sine 1 by x will be less than equal to root of x 1 plus 1, right? And root of x 1 minus 1,
Minus one.
right?
Right.
Correct.
Right.
And because of the squeeze theorem now, right? This
It
is
is zero.
this tends to 0, this tends to 0, right? And
Yes,
these
that's sure.
inequalities are valid, right?
Yep.
So this should tend to 0, right? Because of the outside part.
Yep.
Correct.
Correct.
Individually, the limit does not exist, but because of this function, which is tending to 0, it is squeezed and becomes 0, right?
Yeah.
So limit from positive side is tending to 0. From this side, I will do the same thing actually, nothing different, right?
Yeah.
Individually, limit will not exist, but because of the squeeze principle,
It will again tend to zero.
again tend to 0. So it will be continuous for sure, because both limits are tending to 0.
Yeah.
Continuous it will be. Differentiable, I highly doubt it. Uh, Differentiability will not happen because uh, we can take the limits again for differentiability. The limits will be different. Like, okay, let's just verify it actually. Look at the definition and look at it from there. You could also do it by actually differentiating this part and this part and checking the value at 0. You understand what I'm saying?
Yeah.
So one function you can differentiate, the top function, and then the bottom function, and checking the value when it tends to 0 and all. If they are different derivatives, then they are not going to be differentiable. So let's do that first actually. 1 by 2 root x plus, I have to differentiate root x into sine 1 by x. So I will do it like root 1 by 2 root x sine 1 by x plus root x into cos 1 by x into minus 1 by x square, right?
Yeah.
So the problem here is that infinity, infinity, this becomes infinity also, right?
Right.
This is totally infinity and all, like very weird values are coming as x tends to 0, right?
Right.
Uh, on the other hand, here will be minus 1 by 2 root of minus x into minus 1. So plus 1 by 2 root of minus x. Similar things, but plus 1 by 2 root of minus x into sine 1 by x. Actually, this method doesn't seem very legitimate because of the fact that you have to put infinities, no? It is tending towards infinity.
Yeah.
So I might as well actually just take limit of h tends to 0, f of x 0 plus h, right? So
Yep.
0 plus h will be root h, 1 plus sine 1 by h minus f of 0. F of 0 is 0
Zero. Yeah.
by h, right?
Yep.
This limit is my f dash f 0 plus f dash x, right?
Right.
Right hand derivative this is. So, okay. So this is slightly better because at least I have 1 by root h plus 1 by root h sine 1 by h, and limit h tends to 0, right?
Right.
I have this value here, and uh, this definitely tends to positive infinity. No, yeah, this is positive. This is positive. Everything is positive, right?
Right.
This tends to plus infinity for sure, right?
Right.
Okay, now I'll do the other side limit. Other side limit will be left hand limit, and I have to do f of 0 minus h and so on, right?
Yep.
Left hand derivative actually. So f dash h 0 minus, right? That
Yeah.
will be equal to limit h tends to 0, and f of 0 minus h will be in this function. So I will do minus of root of minus of, instead of x I have to put minus h, right?
Right.
And 1 plus sine 1 by minus h
Minus.
minus f of 0, which is 0, by h, right? So this becomes minus root h 1 minus sine
And 1 by h.
1 by h by h, which is limit h tends to 0. This becomes minus 1 by root h 1 minus sine 1 by h. So this is becoming minus 1 by root h plus 1 by root h sine 1 by h, right?
Right.
Limit h tends to 0. Okay. Now h is positive here, but now we have to understand which one is, whether it is a positive infinity or a negative infinity. That is what we have to decide. Uh, so this value, uh, okay. This value also, by the way, we're not sure about the value here. We cannot say that this is positive. 1 by h is positive, but sine of 1 by h is very large, no? So we don't know whether it is positive or not.
Or not. Yeah.
We don't really know actually. So mm, we don't see, this is going to oscillate. No, I don't even know what this value is going to be, right? It could be anything between plus and minus 1, right? Sine of 1 by
Right.
h. But I don't know where it will be, plus 1 or minus 1, right?
Right.
I have no idea right now, because 1 by h becomes really large, right? So sine of an
Yeah.
argument which is really large, now it can be anywhere between this, right? Somewhere here, right?
Yep.
Yeah.
So I cannot, for sure, I cannot say for certain that these are equal,
Got it.
because they are, first of all, the expression is also different, and I don't even know one specific value that I can specify, right?
Yes.
It could be anything between 2 by root h and 0, right?
Yeah.
0 to 2 by root h, where 2 by root h itself tends to infinity, see?
Yes.
So actually, and here it could be anything between minus 2 by root h
And
to
z
0. Okay, which is sort of telling me that it is not differentiable, because this is tending to minus infinity
infinity.
and this is tending to 0 to infinity, right?
Yeah.
So I will say it is continuous but not differentiable.
All right.
Continuity was much easier, but not differentiable. But the thing to learn here is that you have to be able to apply your basic definition, the limit definition, in each case, for continuity also and for differentiability also. If you can apply your limit definition every time, then you would, you are guaranteed to get the answer. Okay,
Okay.
what next? Tell me.
And 27.
F double dash x is continuous at x is equal to 0. F double dash x is continuous at x is equal to 0, and f, he's saying f double dash x is 0, no? Not triple dash, right?
Double dash. Yeah.
F double dash 0 is 4. Uh, then value of limit x tends to 0, limit x tends to 0. Numerator has f of 2 f of x minus 3 f of 2x plus 2 f of x minus 3 f of 2x, uh, plus f of 4x by x square plus f of 4x by x square. Okay, this value of the limit is being asked, and the values options are 11 to 12, none. 11 to 12, none. Okay, f double dash x is continuous at x is equal to 0, and the value of f double dash x is given at x is equal to 0, right?
Yep.
So what we know for sure is that limit of h tends to 0, f double dash 0 plus h, right,
Yeah.
should be equal to limit of h tends to 0, f double dash 0 minus h is equal to 4, right?
Right.
Because that function is continuous at 0, right?
Yeah.
Okay, so we know basically limit of h tends to 0, f double dash h is equal to limit of h tends to 0, f double dash minus h is equal to 4, right?
Right.
Okay, and f double dash 0 is 4. That also means double derivative is continuous. So single derivative was differentiable, right there.
Yeah.
Then only you got a double derivative, no? If the f
Yes.
dash x function must have been differentiable there, right?
Yep.
So
Right.
if f dash x is differentiable at x is equal to 0, then that f dash x is continuous at x is equal to 0,
Right.
right? F dash x is continuous at x is equal to 0 means again limit of h tends to 0, f dash 0 plus h should be limit of h tends to 0, f dash 0 minus h is equal to f dash 0, right? We don't know the value of f dash 0 right now, right?
Right.
Okay, but these values must be equal, right?
Right.
F dash x must have been continuous also, no? So okay, uh, f dash x is continuous will mean fx is differentiable. So fx is differentiable means fx is also continuous. Basically, we can say that fx is continuous, f dash x is continuous, and finally f double dash x is also continuous, right? And double derivative is 4,
Or yeah.
right? So, uh, so what kind of functions do you generally find where f dash, f double dash, all of them are continuous, right? Uh, you can think of polynomials when multiple derivatives are continuous, right?
Right.
You could also think of sine and cosine type of functions, right?
Right.
Correct. Those are also everywhere it is continuous and all, right? Uh, in my mind right now, I'm thinking of polynomials because there is an x square on the bottom, right? Uh, I have a feeling it's a polynomial, it's a quadratic or something. F double dash x will be a constant then, right? And f double dash x will be 0 means first constant you will know. Wait, let's think of some other way also. This limit is being asked. So fx two of fx minus f of 0. F of 0 we don't know. F double dash 0 is 4. Double derivative is 4. So what do we know? What does that mean? What it means is limit of h tends to 0, f dash 0 plus h minus f dash 0 by h is equal to 4, no?
Right.
This is saying that in the f dash x function, I'm differentiating it and I'm saying that limit must be 4, right?
Or yeah.
So we have f dash h minus f dash 0 by h limit h tends to 0 is equal to 4. So okay, and similarly you have f of 0 minus 0 minus h also, the other side also is true. So you can say that f dash h must be 4h plus f dash 0, something like this, right? 4h plus f dash 0 is f dash h. Then only the limit value is tending to that.
Yeah.
Uh, this is okay. And f dash h means basically limit of h tends to 0, f of h minus f of 0 by h, right, is equal to 4h plus f dash 0, right? This means what? 0 plus h? No, this means h plus h. That will be weird. This thing means f dash 0. F dash 0. Hmm. One second, let me think. This is being asked. Why is he asking this? Because 2 of f of x minus 3 of f of 2x and f double dash 0 is 4, then value of this limit. See, the only way this limit will have a real value, right, is if the numerator part also tends to 0, no?
Right.
Like if the numerator part is tending to some finite value, then a by 0 will be infinite, no?
Yeah.
So only if it is 0 by 0 form can you say that this will have some actual finite value,
Yeah.
right? So
Right.
I'm going to use that. I'm not going to worry about this right now. I'm going to say limit of x tends to 0 to fx minus 3 f of 2x plus f of 4x by x square has to be in the 0 by 0 form
Right.
for the limit to exist, right?
Right.
So then I can do L'Hospitals here, right?
Yes.
So I will say this is 2 f dash x minus 3 into 2, 6. 3 into 2. No, first I will do 3 f dash 2x into 2. So 6 f dash 2x, right?
Yeah.
Plus 4 f dash 4x, right?
Right.
By 2x.
2x.
So this limit x tends to 0 is becoming f dash x minus 3 f dash 2x, right, plus 2 f dash 4x, right, by x, right?
Right.
Now we already know that, okay, again the same thing is happening. This is tending to 0, right?
Yeah.
This is tending to 0, so
Zero.
this has to tend to 0, right? And also we know
Yeah.
that f dash x and all was continuous and differentiable, right? We had derived all that, right?
Yeah.
So we can do again 0 by 0, differentiate it again. So we get f double dash x minus 3 into 2, 6 f double dash 2x, right?
Right.
Plus 8 f double dash 2x, 4x
Right.
by 1, right?
Yeah.
Limit x tends to 0. So it is f double dash 0 minus 6 f double dash 0 plus 8 f double dash 0, right?
Yeah.
So this is 3 times f double dash 0, which is 12. Okay.
Okay.
So why am I doing L'Hopital? Because I mean I knew that before also, but I was trying to get it without using that, but it was not coming. It was not coming directly from some way. Uh, the reason I was thinking of this was because obviously this is 0, right? So
Yeah.
this top part must also tend to 0, otherwise it will be weird. If it is not 0 by 0, it will be infinite, right?
Yeah.
So L'Hopital you can be used here. Also, I was also thinking of fx could be a polynomial like this.
Right.
If this is the polynomial, f dash x becomes what? 2ax plus b,
P.
and f double dash x becomes 2a, right?
Right.
Which is equal to f double dash 0 is 4, right?
Yeah.
So 2a must be 4.
Right.
If it is a second degree polynomial, 2a must be 4. A must be 2, right?
Right.
And f dash 0 is becoming b, and f dash 0 is b, and f double dash 0 is 4, and f of 0 is c. So finally, if you have this thing, so then you have here, what do you get? If you just put the limit like this here, so it becomes 2ax square plus 2bx plus c minus 3 times 4ax square plus 2bx plus c plus 16, right? 16ax square plus 4bx plus c, right?
Right.
And this by x square, right? The
Right.
value of that limit he wants. So this becomes minus 12a. This is plus 2a. So minus 10a. So plus 6ax square. 6ax square you're getting,
Right.
correct?
Yeah.
And the remaining terms are becoming plus 2bx minus 6bx plus 4bx, right? This cancels.
Yeah.
And plus c minus 3c. So minus 2c plus c, right?
Yeah.
So minus c, right?
Right.
Minus c by
X
x
square.
squared, right? So you're
Yeah.
getting 6a minus c by x squared. You have to ensure that c is 0. Okay. Only if c is 0 will the limit exist. And in that case, a is equal to 2 will happen and 6a will be the answer, which will be 12.
Right.
So the function has to be a quadratic where the third term is 0. It will be a quadratic of this form, 2x square plus bx. Then only
Got it.
it is working out. However, this is not a real solution because I have assumed that it's a quadratic. It could be something else also. But in general, the way L'Hospitals we had done, that could work, right? Because one double
Right.
derivative was given to you. So you have to use that somehow. The only way we can use that is L'Hospitals to do the limit.
Right.
Okay. Uh, Next one is which one?
29.
28 you got.
No, but I'll try that by myself.
Okay. Same thing, use the definition and all. Like
Yeah.
use the definition of f dash 0 and all. Okay. And
Yeah.
you remember that question where we did, where f dash 0 can be defined as limit of h tends to 0 f of 0 plus h, right?
Yeah.
So actually you can say that this is written as 0 plus h minus f of 0 by h, right?
Yeah.
So if you have that and f of 0 is 0, so this part doesn't matter, right?
Yes.
And you have to find out, you are given the value of f dash 0, right?
Yeah.
So
Dash 0 is 3.
3 is equal to limit of h tends to 0 f of 0 plus h by h, right? Now
Right.
try to use the condition here, okay? So the condition that is given in the equation is what? F of x plus y by 3. F of x plus y by 3 is equal to f of x plus f of y by 3,
3.
right? F of x plus f of
Yeah.
y by 3. So that means if you have f of 0 plus h here, right? We can say that it is f of 0 plus h is equal to f of 0 by 3 plus 3h by 3, right?
3. Yeah.
Correct. So the x is this, y is this, right? So it should be f of 0 plus f of 3h by 3, right?
By 3.
Right.
Right.
So I will, and this is 0. So you get this as limit of h tends to 0 f of 3h by 3h, right?
Yes.
Correct.
Yeah.
And that is coming out to be 3, right?
Right.
So that just means that limit of fx by x is so fx by x function, right, is differentiable in R. I feel like that function only will be become differentiable because uh, this is looking like fx by x, right?
Yes.
Mm, see, if h tends to 0, you can also say limit of 3h tends to 0 f of 3h by 3h, right, is equal to 3, no?
Yes.
Right. So we know now basically that limit of x tends to 0 fx by x is equal to 3, right?
Right.
So that just means that uh, limit of fx by x is equal to 3. So an example function of this could be a constant straight line function types,
Yeah.
right?
Right.
Polynomial of 1 degree and all. So that polynomial is differentiable. Fx has to be a polynomial function like that, right?
Right.
So I feel like A will be the answer, but you can like check a little bit. Uh, you can think about it a little more. Fx by x is differentiable, he's saying. So differentiability you have to check in, yeah, at 0 only. So for fx by x to be differentiable, what has to happen? Limit h tends to 0, f of 0 plus h. So f of h by h minus the limiting value of that, which is 3, no?
Right.
F of x by x is tending to 3, no?
3. Yeah.
By
I had.
h. This is the derivative. Hmm. This is the right hand derivative. Left hand derivative will be. Hmm. So it is not sure right now. I don't feel like very certain about this. Hmm. What are the other options saying? Fx is continuous but not differentiable in R. Continuous, I feel. Why am I feeling that it is continuous? Because I know this much. I know this.
Yeah, makes it a constant function.
So
Should be
f,
continuous.
f of 3, f of x is becoming something like 3x, right?
Yes.
Then only it is going to satisfy this type of thing. So makes it a continuous function for sure. Differentiability is not so sure, no? This limit is just right hand limit. Left hand limit, we don't have a very good idea right now. Right?
Right.
Doesn't seem like it has to be equal for sure, no? Doesn't even seem like it is going to be defined. It
Yeah.
if it is becoming fh by h square minus 3 by h, right? And the other one is f of
Right.
minus h by minus h square minus 3 by
Right.
h. Doesn't even seem like
Yeah.
it has to be necessarily defined, right? So I
Right.
will not say differentiability, but I will say continuous it looks like,
Right.
right? So you have to use the property and the definition. So that is the idea. Uh, you're asking 29, right?
Right.
Okay. So question 29. Uh, f is differentiable function with the property that f of x plus f of y is equal to f of x plus f of y plus xy. And something else is given. Limit of h tends to 0, 1 by h into f h, I think. Otherwise doesn't make sense, right?
Right.
It is in a different line, but it should be like this, right?
Yes.
That is given as 3. Then you have to, and here they have said that f is a differentiable function. F is a
Right.
differentiable function. So f is continuous, we know. Continuous it must be. If it is differentiable, it must be continuous, right?
Right.
Then, okay. Differential function with the property and limit. Then f is what? Is the linear function, or if it looks like that or that, right? So, okay. So differentiable function. So let's check differentiability at 0. Uh, we have limit of h tends to 0, f of h minus f of 0 by h. F of h plus f of 0 by h. This is equal to limit of h tends to 0, f of 0 uh, 0 minus f of minus h by h. Uh, this is the meaning of differentiability at 0. 0 plus h, 0 minus h. Okay. From here we get one thing, we get f of 0 is 0 because you get 2 times f of 0 plus 0, no?
Right.
F of 0 is 0 we have automatically. So f dash h is becoming limit of h tends to 0, f of h by h, right?
Yeah.
Which is 3, right?
Right.
And it is differentiable, so the other limit also must be equal only, right?
Yes.
So we are getting f dash h is 3. Okay, f dash h is 3 is convenient, but then fh must be 3h, right?
Right.
fh must be 3h, so it is a linear function, no?
Yeah.
fh must be 3h because f dash h is coming as 3. This is basically derivative only, no?
Yes.
You understand what is happening?
Yeah.
So here this is df by dh, right, is 3. So f will, after integrating, it will be 3h only, no? It cannot be x square, no? You understand?
Yeah. I think. Yeah. Answer says C.
Answer is saying C.
Yeah.
But then we are missing something. 1 second. Maybe we have not used this yet. Uh, okay, is differentiable function. So differentiability at any point k. So you have to say that k plus h minus f of k by h, limit h tends to 0, is equal to f dash of k. We checked right now, we had checked only differentiability at 0. Maybe that is why we got that. Now I'm doing it at a general point, right?
Yeah.
So at any point, it must be differentiable at any point. So f of k plus h can be written using the property as f of k plus f of h plus kh, right?
Yes.
So this will become f of k will cancel, it will become f of h plus kh by h, right?
Right.
Now it is coming. It is becoming 3 plus k, right? This limit is 3
Yes.
plus k, right?
Yeah.
Is f dash k.
Okay. Yeah.
So now it is coming, it is becoming 3k plus k square by 2, right?
Right.
Integral with respect to k. Or basically, you understand what I'm saying, no? This is
Yeah.
f dash x, so it must have been after derivative, it has come as this, right? So the function must be this, no?
Right.
Sure, no, you understand what has happened.
Yeah. Yeah.
Or you can even write this as limit of uh, f dash k. No, you don't need to actually. It's over anyway. This first derivative is a linear function, so function must be a quadratic, right?
Right.
Function must be a quadratic, and quadratic will be like this: x square by 2 plus 3k. That
Yeah.
can be done by integration. Okay, what is, so basically again use the, so the mistake that we made earlier was that we only checked derivative at 0, right? But
Yeah.
you are supposed to check it at all points. It is differentiable means it is differentiable everywhere.
Right.
So when you check at all points, a general point, then you will use the condition and it doesn't become just 3, becomes 3 plus some k, right?
Right.
What is the next one?
30th.
30th is again differential function he is saying. So similar it will be again. F of x plus y by 3 is equal to 4 minus, okay, f of x plus y by 3 is equal to 4 minus 2 times f of x plus f of y, 2 times f of x plus f of y by 3 for all xy, for all xy belonging to real. Okay, find f of x, find f of x, and what is given is that fx is differentiable. Again, that means differentiable at any arbitrary point. Okay,
Yeah.
so then how is the answer a constant function? What is this? Maybe he wants us to find f of some particular value, because if it was a constant function, um, then it doesn't make a lot of sense, no? Like, if f of x is a constant function, what will happen? F of x plus y, that side will be that c, 4 minus 2 to 2c, 2c, 4 minus 4c by 3 is equal to c, right?
Yeah,
Is equal to c, right? Is coming.
yeah,
Therefore, 4 minus 4c is equal to 3c. So c is equal to 4 by 7. Answer will be D, I think.
yeah,
But that is like a horrible question, because the options are saying that it's constant, right?
right, right,
Like, if it's a constant function, then I don't need to do much, no? I will just say this side is c and this side is 4 minus 2 times 2c, right?
yep,
So that will give the answer very quickly, but let's try to solve it, like why it became constant. So if fx is differentiable, let's say that f dash x is equal to limit of h tends to 0, f of x plus h minus f of x by h, right?
right,
And what is this f of x plus h? It is equal to f of 3x plus 3h by 3, right? Correct. And 3x will take the place of this, 3h will take the place of this, right? Correct. So it will be 4 minus 2 times, instead of x I have 3x, so f of 3x, instead of y I have 3h, f of 3h, right,
yeah, yeah,
by 3. This is what is coming as f of x plus h. So I'm getting
yes,
okay, I'm getting 4 by 3 minus 2 by 3 f of 3x minus 2 by 3 f of 3h minus f of x by h, right? That is the value of that limit is equal to f dash x. Limit h tends to 0 also. Limit h tends to 0, right? That is equal to f dash x, right?
right,
If h tends to 0, this part becomes f of 0 and the other parts are not. Okay. Uh, hmm, how will we go ahead from here? F of 0 can we find here? 0, 0, if I put, what happens? 4 minus 2 f of 0 is equal to 4 minus 2 f of 2 into 2 f of 0 by 3. So 3 f of 0 is equal to 7 f of 0. F of 0 is coming as same 4 by 7, right? F of 0 has come as 4 by 7. So sure, no? It's coming. Correct. So this part will become 2 by 3 into 4 by 7. So okay. Hmm. What do I want to prove actually? What I want to prove is that f dash x is equal to 0, right?
Right.
If
F
f
dash
dash
x,
x is equal to 0, then what we get is that function is constant.
Constant. Yeah.
Somehow f dash x must be 0 for all possible values of x.
Right.
Okay, this I have to prove, and I have this equation where if you put y is equal to 2x, if I put, you get 3x by 3 is equal to 4 minus 2 times fx plus f of 2x by 3.
3.
This
Yeah.
becomes f of x is equal to 4 by 3 minus 2 by 3 f of
F of
x
x plus f of 2x.
minus
2
2
by
by
3
3 f of
2x.
2x.
Right.
We're getting 1 plus 2 by 3 is 5 by 3 f of x is equal to 4 by 3 minus 2 by 3 f of 2x, right?
Right.
3, 3, 3 cancels. 5 f of x is equal to 4 minus 2 f of 2x.
Right.
Okay, okay. So we have this. Okay. F of x is coming as 4 by 5 is 2 by 5 f of 2x, and if I had put something else, like can I put some other value to get some f of 2x somehow? F of 2x. To get f of 2x, what I have to put? Y is equal to 5x.
Yes.
Y is equal to 5x. If I put, I will get 2fx this side, and that will become f of x plus f of unknown variable, a new variable will come. So I will not do that. If I put y is 0, I get x by 3 is equal to, okay, I'm getting, let's put y is equal to minus x. So you get this 4 minus 2 times f of x plus f of minus x by 3, right? And this part we had found earlier was 4 by 7 is equal to 4 by 3 minus 2 by 3 f of x plus f of minus x. So you're getting 2 by 3 f of x plus f of minus x is equal to 4 by 3 minus 4 by 7. So 4 into 7, 28 minus 12, 16 by 21. That becomes 8 by 7, right?
Yes.
Right. You're getting f of x plus f of minus x is equal to 2 times f of 0.
Yep.
Okay. So that 2 times f of 0. Uh, okay. And you have this also. So it is fitting every time. Constant function is working out, but why we still don't know. F dash x. Wait, let me do this here. If I do derivative here, f dash x minus f dash of minus x is equal to 0. You are having f dash x is equal to f dash of minus x, right?
I put x is equal to y is equal to 0.
Then what is coming? F of 0 is coming from there, no?
Yeah, f of 0 is equal to 4 by 7.
That we got earlier also. That
Yep.
only I am using here, right?
Yep.
I have gotten this part. Derivative is equal to derivative of f of minus x. So f dash x here is coming out to be minus 2 by 5 into 2 f dash of 2x. So minus 4 by 5 dash of 2x is equal to f dash of x. Okay. Hmm, not really coming, but uh, yeah, it's not coming right now properly. Like, obviously the answer can be gotten very easily, but proof is not coming.
Yep.
Why is it coming as a constant function? X plus y by 3. 4 is 4 minus 2 into fx minus 2 into fy. Uh, f of x plus y by 3 is equal to 4 minus 2fx minus 2fy by 3. So by 3. Uh, so 2 1 minus fx plus 2 1 minus fy by 3 by 3, right,
Right.
is f of x plus y by 3. So uh, f of hmm, can we write x plus y by 3 in terms of some 1 minus fx and all something like that? 1 minus x. Okay, don't worry about it. If I have to work on it, I have to think about it, why it is coming, the proof. But obviously, answer is easy. Like once you know that it's a constant function, it's obvious.
Yeah.
What else? Tell me. Any other questions?
Yeah, 33.
F is real valued differentiable function satisfying this. 33. We'll do it on the next screen. F is real valued differentiable function satisfying fx minus fy mod of fx minus fy is less than equal to x minus y whole square. X minus y whole square for all xy belonging to R. So, okay, and f of 0 is 0. F of 0 is 0. And f of 1 is equal to what? That is what is being asked, no?
Right.
Okay. Real value differentiable function satisfying this relation. So, this relation actually means this mod you can remove, right? Mod you can remove and say that minus of x minus y whole square less than equal to fx minus fy is less than equal to x minus y whole square. No? No matter what the sign of this will be, right?
Yes.
This relation has to be true, this inequality,
Yeah.
right? So why don't we do this? Minus of x minus y less than equal to fx minus fy by x minus y less than equal to x minus y, right?
Yeah.
And this now looks like if you take limit x tends to y both sides, right? Limit x tends to y, right?
Right.
X minus fy by x minus y is the derivative at x, no?
Yes.
Because what is this? This is slope of 2 points, no?
Yeah.
One point is x, one point is y.
What
This
is
is the
y?
y values, right?
Yeah.
So slope of the chord when the chord becomes a tangent, right? Do you understand why this should be
Yeah,
f
I got
dash
this.
x, right?
Yeah.
This is f dash x, and when you took limit of x tends to y here and limit of x tends to y here, both are tending to 0, right?
Right.
0 is less than, so we are getting what? F dash x is 0.
Yeah.
So one value has been given for the function, no? Fx must be constant function.
Mm. Yeah.
So one value has been given for the function, so the other value will also be
0.
0. So the idea is that this mod condition is making sure that this happens, and then divide by x minus 5, right? And
Yeah.
what will happen is that limit of fx minus fy by x minus I will be f dash x, which tends to 0, right?
Right.
Because that tends to 0, your function becomes a constant function. That is the answer, right?
Yeah, got it. My internet connection is unstable.
The answer is correct, no? You checked, right?
Yeah, it's right.
Hmm. Then what else?
35.
35, you have to find, okay. 35 is again some piecewise defined and GIF and all is there. 35, fx is 1 minus mod x by 1 plus x when x is not equal to minus 1. 1 minus mod x by 1 plus x. X is not equal to minus 1. And when x is equal to minus 1, it is equal to 1. Okay. Now you have to find about f of GIF of 2x. F of GIF of 2x. You have to find whether this function is continuous at x is minus 1, continuous at x is 0, or discontinuous at half. Okay, so continuity you have to check at x is equal to minus 1, 0, and half, right?
Right.
Okay, so what we will do is we will check each of these points one by one. So first find the function values at these points, right? So f of 2 into minus 1, right? That is
Yeah.
what? That is f of GAF of minus 2 is minus 2 only, right?
Right. Yeah.
F of minus 2 will be which function? This function.
Yes.
So that will be 1 minus mod of minus 2 will be 2. 1 minus 2 by 1 plus minus 2. So minus 1, right? So this becomes minus
Minus.
1 by minus 1. So 1, right?
Right.
So the f value at minus 1 is 1, right?
Yeah.
Now you have to take limit as x tends to minus 1
Minus
plus
1.
and limit as x tends to minus 1 minus
Minus.
for f of 2x GIF.
GIF. Yeah.
F of 2x GIF. So if x is going towards minus 1 but from from the positive side, right? So it will
Yeah.
go from minus 0.9 so on to minus 1.
Minus 1.
So when you do 2x, it will be minus 1.8 and so on till towards minus 2, right?
Yeah.
So GIF of that will be minus 2, right?
-2.
It will be f of minus 2, right?
Yeah.
F of minus 2 we got earlier was same as 1, right?
Right.
F of minus 2 is becoming 1. So that limit is fine. This limit, f of 2x, right?
Right.
F of 2x, but now the same minus 1 only, but going from the other side, right?
Yeah.
Going from below, right? So it will be minus 1.1 and so on. So minus 2.2 and so on. So this will be f of minus 3, right?
Yeah.
Correct.
Yeah.
Minus 3, what is the value? 1 minus 3 by 1 minus 3, right?
3. Yeah.
So minus 2 by minus 2,
-2, which is 1.
which is 1, which is continuous again, right?
Right.
Correct. So it is becoming continuous at this point, right?
Right. I got it.
So similarly, check
I'll be
all
able
the
to do them.
points. Yeah, so you'll be able to do it. Oh, it is coming. Okay, first option is right. Maybe it is D because might be all or right.
Right. I'll check it out.
Hmm. 36 is obvious. E power 2x and or something like that.
Yeah.
36 will be exponential function. Just make sure that it satisfies all the conditions.
Right.
Yeah.
37. I'll try it out by myself. 38th one I didn't get.
Okay. 38. 38th one is fx value of f0 so that the function becomes continuous. So basically you have to find limits, right?
Right.
Whatever is the value of the limit, that should be the value of the f0, right? Correct. So limit x tends to 0 you have to find for this particular function. Root over a square minus ax plus x square minus root over a square plus ax plus x square plus ax plus x square by you have root over a plus x minus root over a minus x, right? So what I'm saying is the limit value at this should be equal to f of 0, right?
Yes.
Only then it will be called continuous, right?
Yeah.
And a is positive is given to us, right? So so this is a straightforward limit question, no? The,
Yeah.
the way to do it is rationalize both. It's a double rationalization. You understand?
Yeah.
I will multiply this minus this by root a plus x minus root a minus x. I will rationalize denominator by doing this,
Right.
and I will also rationalize numerator by doing this. Okay,
Okay.
this is still 1 and 1, no?
Yeah.
There is no change by multiplying this, right?
Yeah.
However, the change is that it becomes simple, this part. So
Right.
this part becomes uh, a plus x, this was a plus x minus a minus x, right?
Exact. Yeah.
And this root plus this root, right?
Yeah. Right.
And this part will become, I will take this a square minus ax plus x square minus a square plus ax plus x square, right? Correct? When you rationalize this top part, no?
Yeah.
And what is left is another thing is a plus x plus a minus x, right?
Right.
Correct. So what does this become? This becomes a square cancels, minus ax minus 2ax, and x square cancels, right? Here you have minus 2ax, here you have a cancels, and this becomes 2x, right? Correct. Are you getting? This is 2x, this is minus 2ax. Hello? Hello? Hello?
Yeah, my internet connection is unstable.
Yeah, but you're getting, what is happening?
Yeah, I understood this part.
So this becomes minus a, and now I can put the limits very easily, no? X tends to 0, there's no issue only. This
Yeah.
part becomes root a plus root a, so 2 root a, and this part becomes root over a square plus root over a square, right?
Yeah.
So that becomes 2a, right? So
Right.
this is minus 2a root a by 2a, right?
Yeah.
So minus root a, I'm getting, right?
Right.
So that is the answer. The value of the f naught should f0 should be minus root a.
Got it.
Whenever you see irrationals and all, no, rationalization is the best way.
Okay.
And if both are in their numerator and denominator, just do both, rationalize both. Also, you could have done this question by L'Hospitals. It might have been long and annoying, but it can be done by L'Hospitals also.
Yeah.
Okay, this is better though. Okay, anything else?
The 46th one.
Fx is equal to p mod sin x plus q e. Okay, fx is differentiable. So, okay, fx is equal to p mod sin x plus plus q e power mod x plus q e power mod x plus r mod x whole cube plus r mod x whole cube. Fx is differentiable at x is equal to 0. Then you have to find some conditions, right?
Right.
So differential means it has to be first continuous. So let's do continuity first. Continuity at x is equal to 0 first. So that implies f of 0 should be equal to the value of the limit, right?
Right.
F of 0 is this part becomes 0, this part becomes q,
Yeah.
and this part becomes 0, right?
Right.
F of 0 is q, right?
Yeah.
And now I will take limit as h tends to 0 from the positive side, right? The positive side, this will become p into sine h is positive, so sine h is positive, so sine, it is close to 0 also, so that will be p sine x, p mod sine h plus q e power h
H.
plus r h cube, right?
Right.
And since sine h is positive near h is 0 from the positive side, so this becomes simply p sine h plus q e power h plus r h cube, right?
Right.
This must be equal to the h tends to 0 of p mod minus sin h, right?
Yeah.
Q e power minus h
H.
plus r minus h whole cube, right?
Right.
So limit h tends to 0 here, minus p sin minus minus. So again, this is same p mod sin h plus q power minus h plus r minus h cube. Limit h tends to 0. So these two limits must be equal, must become q, right?
Right.
So these two limits are in this and this. So obviously, uh, you're not getting any conditions here, no? Like it's because this is tending to 0, p is gone, and this is also gone, right? Doesn't
Yeah.
matter. You'll get q is equal to q, right?
Yep.
I don't think you get any conditions from this one, right?
Right.
So you just know that f0 has to be q, right?
Yes.
Uh, okay. Differentiability, for differentiability, what you can say is the function for positive x, function fx is becoming p sine x plus q e power x plus r x cube for x greater than 0. For x less than 0, right?
Yeah.
Sin x will become negative, so it is minus p sine x, right?
Right. Yeah.
Plus q e power minus x
Right.
minus r x cube, right?
Right. Yeah.
Now derivative from this side and this side both should match
Should be
near
equal.
0. So you should get p cos x plus q e power x plus 3r x square should be equal to minus p cos x plus q into minus 1. So minus q e power minus
Minus
x
x.
minus 3r x square,
Right.
right? And
Right.
near x tends to 0, this derivative becomes minus p minus q minus 0, and this derivative becomes p plus q plus 0,
0.
right?
Yeah.
So you should have p plus q is equal to minus of p minus q. So p plus q 2 times is 0, so this is 0, right? You
Right.
should have p plus q is equal to 0 for sure, right? For derivatives to match.
Yeah.
And then nothing else. I think that is the condition. Let's see.
So p plus q is equal to 0 and r is
R
equal.
can be anything. There is no restriction on R.
So 46D.
Hmm.
Next one was 50.
F is an even function such that this limit has some finite non-zero value, right?
Right.
Even function means f of x is equal to minus
F of.
f of minus x,
Right.
and limit of h tends to 0 plus, limit of h tends to 0 plus fh minus f0, fh minus f0 by h, right, is equal to, has some finite non-zero value,
Right.
finite non-zero value. So if it has some finite non-zero value, denominator is becoming 0, so numerator must be becoming 0 also. How will it have a finite non-zero value, right? This
And
limit, think of this
also
limit.
tends to 0.
Numerator also has to tend to 0, no? Correct? You are understanding what I'm saying?
Yeah.
It has to be 0 by 0 form, no? Then
Yeah, like the previous ones.
so it has to be that, otherwise it will not be finite, right? So
Right.
this limit can be done by L'Hopital. It will become f dash h, and this is constant by 1, right?
Right.
Limit h tends to 0 plus f dash h is equal to the finite non-zero value.
Value.
Non-zero value. So what is being asked for us? F is continuous and derivable. So we are getting f dash x is finite and non-zero, no?
Yeah.
F dash x, if it is finite and non-zero, means you can differentiate it basically, right? You understand?
I lost you for a second.
What I'm saying is, f this limit is finite and non-zero, no?
Yes.
That was the limit of this, right? And
Yeah.
since that means that f dash h is finite and non-zero,
Yes.
right?
Yeah. So it's
So, and also the function is like this. It's an even function, no? So
yeah.
whatever happens this side, symmetrical things will happen this side, right?
Right.
F dash h here and here. So is it saying non-derivable that x is equal to 0?
Yes.
B is saying, no?
Yeah.
Oh, makes sense. Because if it is an even function, then notice that the graph is like this, right? Then this was a right hand derivative, no? Near x is equal to 0, right?
Yeah.
If your graph is a reflection like this, then this side will be like this, no?
Like that. Yeah.
You understand? Your
Yeah.
slope will not be the same left hand derivative.
Yeah. It will change.
It has to change, no? If,
Yeah.
however, it was like this, then it would have matched. If it
Right.
was odd function, no,
Yeah.
it would have been derivable. But here it has to have some sharp turn somehow because
Got
it
it.
is a reflection, right?
Yeah.
So that's why it is continuous, but it is not differentiable.
And 52.
Signum function, you know what it is.
If it is one, if it is, if it's zero,
Positive,
then
it is
zero.
1,
Yeah. And if it's negative, it's -1.
and if it is 0, it's 0.
0. Yeah.
So you have to just decide whether this function fx is equal to sgn uh, cos 2x minus 2 sin x plus 3. Cos 2x minus 2 sin x plus 3. This function is continuous or has a missing point, discontinuity, what type of discontinuity, and so on, right? So let's find out. Okay, so first of all, okay, this is not a problem. This is a constant function. It's always 1. Why? Because I know for sure that, oh, wait, 1 second, I'm not sure now. Okay, I was very hasty, but I was trying to think that this maximum value of this, but now I'll do it properly. So notice that this is 1 minus 2 sine square x, right?
Yeah.
Minus 2 sine x plus 3. If it was cos x minus 2 sine x plus 3, then my answer was correct. Because I know maximum value of this is root 5 and
Right.
minimum value is minus root 5, right?
Right. Yeah.
So that means 3 plus that will always be positive, no?
Yes.
So then it would have been a constant function,
Right.
right? But in this case,
Yeah.
it was cos 2x. So therefore, now I have to do it properly. So this becomes 4 minus 2 sine x minus 2 sine square x, right?
Yes.
So 2 common, 1 minus 2 minus sine x
That will be 2 minus.
minus sine square x, right?
Yeah.
Okay. So this part we have to figure out. But we know for sure sine x is, okay, this is positive always. You understand,
Right. Got it.
right? This is always positive or 0. 0 is a possibility, right?
Yes.
Near, say, sin x is pi by 2, right? When x is near pi by 2, in that case, it could become 0, right?
Yes.
Otherwise, it is always positive. Only and the odd multiples of pi by 2, it might become 1 and all.
Yeah, so to very close to 0.
So those points I have to check for discontinuity, right? Because suddenly it will become 0, right?
Yes.
Any other point, this thing is always going to be less than 1, and this thing is even lesser than that, no? Like
Yep.
sine square x will be lesser than sine x also, and it will be less than 1, right?
Yes.
So there is no doubt that this part will be positive.
All,
So it will have removable discontinuities, no? Because you will have to lift your pen to draw the graph, no? Sometimes it will have one value. Like everywhere it is going to be, function is going to be 1 except some place where it is 0.
yeah, and again the same. Yeah, got it.
So that is a removable discontinuity. You can define it to be, you can remove this point and make it 1, right? You can say function is defined such that at x is equal to pi by 2, it is 1, right?
Yeah.
Are you understanding removable why it is?
Yes.
Right. So you will say, I think C. You should say C. It is not missing point discontinuity. It is also not irremovable.
Okay.
What is the answer given?
See.
You understand why, no?
Yeah.
Okay. Okay. So try whatever is left, right? You are understanding the chapter, no?
Yes, I am.
So try whatever is left. Maybe if needed, we'll do one more doubt class. Okay.
Oh,
But hopefully, if not too many more doubts are there, then we'll start differentiation and application of derivatives in the next week's class. Okay.
fine.
Just keep trying. This is good. If you have done all this, then you will feel better. And this is all important stuff. Like all of these concepts, the limit definitions, continuity, differentiability definitions are super important. Like you need to be very clear about how to use all of this. And the more you practice, the better it will be.
Okay.
Tomorrow we'll
Yeah,
do
sure.
physics. Okay. Just continue doing this exercise 1, exercise 2, and as much as possible. Like, and hopefully you'll feel confident also. If you are feeling like it, you should try the JE problems. Try the JE problems. That will help you even more because then you will realize
Oh,
कि actual questions in the exam are how, right?
okay.
Okay. That's all for now then.
Thank you.
Bye.
Bye.